Example 2, Johnny ran toward the town at 10 kilometers per hour at 10 a.m. At noon, Thomas began to chase him from the same starting point. If he caught Johnny at 2 p.m., how fast did he run? So, let's take a look at what's going on. Yeah, they're going really fast. Maybe. I don't know. We'll see. Kilometers, like, oh, that'd be like 6 miles per hour.
Yeah,
that's more than a jog. That's pretty decent pace. So Johnny's running towards town at 10 kilometers per hour. So this is Johnny and this is Thomas.
Thomas is going to kill him.
All right, and Johnny's running towards town. It doesn't tell us where town is, but we're going to assume that Johnny continues to run because he's got all the energy in the world. All right, and he's going to travel for some unknown distance because it doesn't tell us how far he runs, right? Nowhere does it say Johnny ran for 50 kilometers. It just says he ran. All right. Now notice, Thomas began to chase him from the same starting point. He caught Johnny. So let's consider this. If he left from the same starting point, and the end of the problem, he caught Johnny, what do we know about the distances? They're equal to each other. All right, so Thomas has to go, of course, faster than Johnny because he's got to catch him. He left after he did, right? So distance of Thomas should equal distance of Johnny.
It's an epic game of tag.
What's that?
Epic game of tag.
Yeah, it is an epic game of tag. Yeah. Thomas started 2 hours late, though, so that's kind of rough. All right. So let's, again, once I've established the distances are equal to each other, and again, that's the type of thought I want you to go through in these problems right now, because they're going to be equal. That's fine. But know why they're equal. Get an understanding of, well, the last time they made the same trip, this time they had the same starting point, and he got caught, so they had the same ending point. The distances are the same for that reason. Every one of these has a reason why the distances are equal to each other. And when they start throwing in the other problems where the distances add up to a number, or the distance plus a number equals another distance, and that kind of thing, you want to make distinctions between the problems. Okay? Once you've established those distances are equal to each other, now we need to start investigating rates and times. Okay? Johnny ran toward the town at 10 kilometers per hour. That is Johnny's rate, right? Oh, get that 10 a.m. All right. So Johnny, 10 kilometers per hour. Okay, that unit of speed, kilometers per hour, immediately tells me my time unit is hours, my distance unit is kilometers. I'm not going to count a problem wrong because you put the wrong unit on it, but do get an understanding of units. It's helpful sometimes to get your brain wrapped around a problem. How fast is Thomas running?
Oh, we don't know. We don't know.
How fast did he run?
Here's the question.
He being Thomas, right? So we don't know how fast Thomas ran. So I'm going to put an R there for his rate. All right, I'm allowed to use one variable. I've already used it, which means I have to know time. Okay, so now let's think about time here. Johnny started at 10 a.m. Thomas began to chase him at noon. And be careful of noon and midnight. Okay? Words that represent time of day. All right, noon is 12 p.m., midnight is 12 a.m. All right, so Johnny started at 10 a.m., which is right about now. Okay, 2 hours later, noon, Thomas began to chase him. And he caught Johnny at 2 p.m. So look at this scenario. I know what time Johnny left, right? And I know what time he got caught. How long did he run?
4 hours.
4 hours, very good. 10 a.m. to 2 p.m. is 4 hours. Thomas started at noon and caught Johnny at 2 p.m. So how long did he run?
2 hours.
2 hours. If you know the beginning time and the ending time, you can figure out how much time has passed. This time here is elapsed time. Elapsed time is how much time has passed, not what time does the clock say. All right, I've seen people do this problem and put 10 and 2 because they don't see the noon and they see times and it says times, so they write 10 and 2. And get the wrong answer, obviously, because it's wrong. But just be careful. The 2 happens to be right, but that's just luck. All right? But the 10's wrong, and you have Thomas running 50 kilometers per hour. He's probably got a heart attack halfway through because he's running so fast. Nothing good happens. So anyway, 10 times 4 is 40 for Johnny's distance, and 2 times R is 2R for Thomas's distance. The distances are equal to each other, so Johnny's distance equals Thomas's distance. We divide by 2, we get R is equal to 20 kilometers per hour. The question does ask, how fast did he run? The answer is right there, 20 kilometers per hour. All right?
Okay.
He's going right around 12 miles per hour. That's pretty fast. He really wants to
For
catch
2
it.
hours.
That's right.
For 2 hours.
Yeah. Johnny took off, and then Thomas saw that Johnny had dropped something. He dropped his.
2 hours later.
Yeah, he's like,
Dude!
Johnny! And he's yet, you can't even hear him. He's so far ahead of us. Yeah. And he just takes off. Wow. That's a good friend right there. You dropped your peanuts. Right? Because he had some peanuts. Because he bought the peanuts because he likes those. He had no allergy or anything. So, yeah. All right.
Running out of place.